brute force at work. A European Ariane 5 rocket lifts off from Kourou. For Bepi Colombo, Europe's first mission to Mercury, the real journey has begun. Its 7.5-year flight is a major challenge in orbital mechanics and will see it reach the smallest and innermost planet in our solar system in 2025. There, its discovery mission will really begin. A joint program with the Japanese space agency JAXA, Bepi Colombo is one of the most complex scientific missions ever launched. It carries 2 orbiters designed to unravel many of Mercury's mysteries. These include an unusual magnetic field, strange surface features called hollows, and ancient ice hidden in polar craters.
One spacecraft is provided by ESA, which is MPO, we call it MPO, Mercury Planetary Orbiter. And this spacecraft has a focus more on the planet. We want to observe the planet, do remote sensing, characterize the surface, count the craters, wanting to know about the composition of the surface, the interior of that planet. And in addition, we have a second spacecraft, and this spacecraft is called the Mercury Magnetospheric Orbiter, more focused on the environment, and this spacecraft is provided by the Japanese Space Agency.
We know the Mercury is very hot, and we have to make the satellite that can survive in that harsh environment. And we know, well, it is very difficult, and when we started, we already some development, and we think that we can do it. But actually, the hurdle is much harder than we expected, and takes a long time. But now we see this is a flight model.
Bepi Colombo's road, design, research and development phase, the construction, assembly and testing phase, has been long and hard, culminating in the launch from the European spaceport in French Guiana.
Mercury is 3 times closer to the Sun, and therefore the radiation or the heat which we are getting from Mercury is 10 times higher. So everything which we had to develop had to withstand the higher temperatures, but also the higher radiation doses which we got from the solar wind. And for that we need special insulation of our spacecraft, special materials to be developed for the antenna, for the solar panels. And that was a very big challenge for the mission in itself.
Now, of course, we do the health checks to verify the system is healthy. And we did alignment, mechanical checks, electrical checks all over. We checked the propulsion subsystems to see if the propulsion elements are still leak tight in preparation for the fueling.
Hardware apart, training of the scientists and technicians back on Earth was extensive, requiring years of preparation.
The simulations campaign is the first time that all the experts involved in the Bepi Colombo spacecraft design, integration, testing and operations work together as a single team. The campaign is essential for this group to learn to work as a single team, to train the decision-making process. The campaign is also very important for us to fine-tune our plans and procedures. It's the first time that we exercise the flight plans and procedures in a realistic context. taking into account communication constraints, ground station, and timing.
In preparing for a mission like this, we have to carefully train all the aspects. What we actually do in the rehearsal, we do in preparation of a launch, we train the teams to work together, we train the teams to work with the flight procedures, and also we train the teams as much as we can in flight conditions. So normally when we test before, we test with many workarounds. What we try to simulate here is actually to replicate as much as possible flight condition, and we typically do between 20 and 30 of these rehearsals before a flight.
With the nail-biting launch sequence complete, for many it's time to sit back and wait.
The cruise will be just above 7 years. We will fly by once the Earth, 2 times Venus, and 6 times Mercury itself, before we come into the orbit, which allows us to capture with the small gravity of planet Mercury against the big sun. That means when we fly, we constantly brake against the sun because we fly into the inner side of our solar system. Yeah, and when you fly towards the most heaviest element there, you constantly accelerate. We don't want that. That's why we decelerate.